a man of mass 75 kilograms is standing in a lift of mass 600 kilograms, which is accelerating upwards. The cable of the lift has a tension of 8,000 newtons. Part A. Draw separate diagrams showing the forces on the lift and on the man. And then B. Find the acceleration and the reaction of the man on the floor of the lift. Okay, so first step, we have to draw the diagram. So I'm going to draw the lift and the man separately, because it just says separate diagrams. So on the lift, what's acting on the lift? Well, we've got its weight, which is going to be 600 G newtons, G being 9.8, and then we got the reaction of the man standing on the lift, so that's going to be R newtons, and then we've got the tension 8,000 newtons upwards. On the man, we've got don't forget that there is an acceleration, and that should be on the force diagram as well. On the man, we've got his weight acting downward, which is 75 G newtons, and we've got the normal reaction of him that he feels standing on the lift floor, which is R newtons, and we've got the acceleration A meters per second. Okay, and what we've got to find is A and R, two unknowns, so that should suggest that we need two equations. So if we resolve both situations separately vertically, then for the lift we got 8,000 minus R minus 600 G is equal to the mass of the lift, which is 600 kilograms. So that's going to be equal to 600 times the acceleration using Newton's second law. For the man, we've got the normal reaction acting upwards, and then we're going to take away his weight, which is 75 G newtons, and that's going to be equal to 75A. We call that equation 1, we call that equation 2. We've got two unknowns in each one, therefore we should be able to solve them simultaneously. So if we just do 1 plus 2, that's going to give 8,000 minus 75G minus 600G is equal to, adding these together, it's going to give me 675A. So A will be equal to 8,000 minus 675G divided by 675. If we work that out on our calculator, we get 2.051. And to three significant figures, that will be 2.05 meters per second squared. Keep this value in the calculator, put it in the memory or something, because we're going to need it in the second part. And then to find R, we just substitute into 2, because that would be the easiest of the two to do it. You can substitute into 1 if you want. So we're going to have R minus 75G is equal to 75 times 2.051. Don't use the one that you've rounded off. And therefore R will be 75 times 2.051 plus 75G, which will give me 888.8. And rounding off to three significant figures, that would be 889 newtons. So this has been a video to show you how to solve a lift problem. So drawing the diagram separately, coming up with the two equations, and then using it to find the acceleration and the reaction of the man on the floor of the lift. I hope you've understood, and I thank you very much for watching.